Welcome back to Made Up of Wires, where we're decompiling Castlevania Symphony of the Night. Go to soten.z.dev to learn more. I'm going to try to go a little fast today. I get out in about an hour. So we'll see where we get. Alright, let me get my stuff straight here. There we go. Alright, so what are we working on? We're working on Aurochs today. Still. Go to soten.z.dev to learn more. Source code, Discord, you know all the things. Like, subscribe, encouraging me to keep going. I mentioned yesterday I've been doing this for almost 2 years. Next month it'll be 2 years of decompiling. The project is about 2 to 3 years older than that. I came in quite a bit later. I did get my environment fixed. But we're not going to be looking at that today. We're going to go to the main Aurochs function. Oh, and I hope I didn't lose my stuff. I hope I saved yesterday. Let's hit Command S and pray. Oh, I might have lost it. Oh, we'll see. Such is life. Oh, you know what? I have a Blender render going. I'm gonna have to cut that out. I cannot do all the things at the same time. Sorry, render. I'll get back to you later. I'll talk more about that when that project's done. Whatever Blender does, though. So all the drivers now for macOS are in user space, and so they're competing for priority just like any of your other programs are. And so when the scheduler can't really decide, especially it seems like with maybe GPU bound tasks, when the scheduler can't decide what to do, the networking process takes a hit just like everything else. We'll get this going though. Interesting. I have a 11 gig Amazon process. Amazon.com. All right, let's get validated as a human. Would anybody watch a stream where people just did CAPTCHA validations? I doubt it. Maybe. Okay, so where were we? Basically going through this gigantic function. So this is the main function for the Aurochs entity. We have a couple things in here that I haven't figured out yet, what the types of certain things are. They could be entities, they could be primitives, not sure. I'm going to just go through and poke around a little bit, and as I'm poking, maybe I'll see something that looks like it could be systemic, and then we'll go through and fix those. So there are certain things that are less than that. And we can fix those as well. And I'm kind of looking over here. So if you're not familiar with the decomp.me interface, we have a text editor with C code. We choose our compiler and compiler settings in the options. The output of that is in this far column here. That's the code that we're compiling as MIPS machine code. And then we have our target code that we pulled from the game disk here. And so we're trying to get this column to match this one by the things we do here. And so I see just a few minor things, not anything super egregious, but Just some things to try to fix out. It looks like args here probably are wrong. I do have symbol updates here, so some of these symbols might not be right anymore. And we might have to import this. So here we're getting some stuff from entities that doesn't seem to be pulled in correctly. We're missing a load from the entities table. This is the player entity. It looks like we're moving the player into a variable and then doing nothing with it. That's how I read that. Now we'll come back to that in a little bit, though. There's some other work with entities that is being done later. Oh, that's what it is. I see what it is now. It's this here. It's not going to G entities directly. It's going to player. So let's use that entity variable. It could be a player variable specifically. Every once in a while I know what I'm talking about. Not often. So we have a bunch of masking here that is likely unnecessary. This looks like it's just facing left. SPE3, SP3E, we're going to call that facing left. And let's go up here and find that facing left, and it should be a Boolean, or not a Boolean, sorry, it should be on side 8. And it is. You can look up these other ones as well, SP3F. My guess is that this is also facing left. But without knowing more, it's hard to know for sure. And usually facing left is treated as a Boolean. So I know I'll get some free points just by getting rid of the not equal 0. Let's just get rid of all of those. Anytime we see facing left does not equal 0, we're just going to change it to facing left. And let's go back to 328. Those are going to be very minor compared to other things that are happening here. I should do a little bit more work on this. It looks like we could have an offset X, and we already have that. So let's do that. That'll be our next thing. Any var s5 variables, any variables that are prefixed with that, we're going to change to offset X, as long as everything around it is related to the X variable. And we have a lot of var s5s. But my guess is most of the time that is what that's going to be. So 3, we're going to do all those. And this is not going to compile at the moment, but that's fine. Those. And the reason is because as I replace these, the declarations are getting updated as well. And we're creating more and more offset X variables. This will aid in getting rid of a bunch of these additional variables. I'm going through them one by one, mostly because I don't know if that register is always used that way, and I'd rather be safe. The extra time that it takes to go through these one by one is much less than if I would just do a global pattern match and replace. So far, that looks like it would have been a safe choice. Okay, so we got rid of all those, and they all were, in fact, offset X. We probably have something similar for offset Y. Look at that, 33%. That gave us 5% bump just unifying that variable. Let's look at some of these other ones, var S3 and the like, and see if we can find another pattern like that. My guess is that there is a Y variable. Usually there is a Y offset Y variable as well. Orox isn't a very vertical boss fight though, so maybe not. Let's look for scroll Y. Oops. So there was some interesting, yeah, no Y. Sometimes Y is still set, and we might not necessarily see it in M2C's decomp, but it may show up in the code. M2C sometimes will eliminate dead stores early. This one I know is going to be a thing. Did I do all the G APIs? I think I did. Okay. So there's a couple ways we can continue. We can keep looking for what the entity extensions are. Anytime we have a legal, we need to figure out what that is and replace it with a field that we give some meaning to. That's useful. The next thing, and it's probably the most reasonable thing to go-tos is kind of nice. Be kind of nice to do. This is kind of interesting. So here we have a case where we don't want to break, we want to jump down here. In all the other cases, we do want to break. So we only have 2 cases here. So if fails, we're going to go down here, which is fine. If we enter here and go here, then we're going to call this and break. Otherwise, we're going to fall through. I think that makes sense. And then we can get rid of that. Else. And then there's going to be cases like this too, where we have a superfluous variable, and we need to figure out if we should be using that. Looks like not. Here it doesn't make sense at all. And that also doesn't make sense, so we can get rid of all of the variables. Label. I think that this is an accident. So I'm going to get rid of that. Some of these we probably need to go through and also figure out what these other functions are taking, and that might help us determine what some of these types are. So we might have to step away from this for a little bit while we try to figure out what else might be going on. I missed this earlier. 364. And this might be good to look at as well. Should be able to get rid of most of these. So M2C doesn't know pointer arithmetic, so it just adds the size, even though it knows what it's pointing to most of the time. It seems like it would be a nice research project for somebody. See if they could teach M2C how to do pointer arithmetic. But now we should start seeing the correct numbers here. Not quite. But those are going to be closer at least. 1 second. All right. Yeah, a bunch of these I think are just the wrong just the wrong registers, and so M2C can't figure out if they're arguments or not. So if you're not familiar with MIPS, MIPS has all of its registers are general purpose, but some of them are given names to be used for certain purposes. And when they're not being used for that purpose, they can be used for other things. And so that sometimes that will happen. And a decompiler can't tell then if it should be used, for example, as an argument register, or if it's just being used temporarily. And that's what's happening here. That happens more so on the PSP. Here we have a check for a switch value. I'm going to change this to a not. Let's go to 411 and see if we can tell what it is from there. It's possible that both compile the same thing. No, this adds an extra mask, so that is correct. We could look for that as well, but it looks like this is basically the same thing as the other one. So we're going to break here. Otherwise, we're going to just fall into the section down below. And that might not be necessary to get this to compile correctly. It might be, but it's better for humans to understand, easier for humans to understand. And that's part of all of this as well. So there are some decomp projects, especially automated decomps, that will take a function and basically emit functions that represent every instruction. And then that would allow you to come in and rewrite it whatever way you want. And yeah, that could work, but at the same time, it doesn't help anybody know any more about that project. So it's not something that I think has a lot of value. The main value, I guess, is that you can retarget that code then and recompile it. It doesn't help with understanding it. We're seeing this a lot. So this SP3F going into this particular offset, it might be time to go through and try to figure out what that is. It does look like that's going to be Sorry, just replacing all these offsets while I have the number. A lot of them. So it could be like a facing direction that's, or just really any type of flag at all. Let's go through and see if we can make some sense of what that might be doing. I'm going to go to the top and we'll kind of come down and see. So when we start out, we're initializing. This is the first case. We're setting this flag to 1. So I think when Olrock starts out, he's on your right, so he would be facing left. But entities do have a facing left pointer. It could be what side the player is compared to Olrock's. And basically we're changing, I had these as primitives, we're changing what field we're looking at depending on one or the other. This might not actually be a primitive. We know it's a pointer to something, but maybe not that. I am going to get rid of all of these cases where we are masking this. That does not seem necessary. It's already coming in as an unsigned 8. The compiler will do the masking for us. Okay. Let's keep looking. And so we're doing these offset comparisons, and it definitely seems like this does have something to do with either what direction is the player compared to, I'm assuming that this is the Olrock's entity. So sometimes that's called side to player. But why would we have potentially a different entity pointer? I don't know. Well, let's keep looking. And we do have another Boolean field. They are Booleans, but they're don't do that. They're being treated as Booleans, but they're unsigned 8s. Boolean is usually, actually, a Boolean's undefined in C as to what its size is. Only that it needs to be big enough to store a 0 and a 1. Let's look at this. This, as I said before, I've been pulling these in as primitives, but this might give us a hint as to what this is. So I'm going to flip over to the terminal. We're going to look at that. We're going to look at the entity. What I want to see is what is that offset 1C of the entity? That's scale Y. That doesn't make any sense. Let's also look at primitive. And it's possible that this is just its own struct. Which I'm kind of hoping it's not. These are going to offset 18. And that, yeah, it doesn't look like that. So let's look at other things that might have something interesting at offset 1C. A collider. The collider's not a pointer. It looks like something with a pointer. I don't think it's graphics. I think it's a struct that we don't have yet. And what about unknown 18? Okay, so it's not a primitive. And it's something that looks like it has relationships to other entities, possibly of the same type. So I think we're gonna have to start building something up like that. So originally, offset U1 was being used, and U1 is... Where's U1? U2. Oh, that is the wrong one. U1 is at offset 18. So I think that's what's happening here. I have it pulling from U1 even though offset... And I'm confusing myself. That's 4. I think that's kind of the key, though, that this is not... These are not primitives. These are a new struct that we don't know about yet, and we're going to have to build. So what do we know about that? We know that it has a pointer at 1C, and that points to something at 1... that pointer points to a struct with a shape that has some type of comparison that looks like it's an offset X at offset 18. Let's do that again. Let's look through here and see for everything that has something at offset 18. Velocity is not the worst. Do we have other things that... Collider. But this could be its own thing too. So the other thing we need to look for is, do we have any arithmetic around this? That we can tell what the size of that is. I don't know that we do. But that may be worth looking at. Let's do this, actually. Let's look at how that entity extension gets set. And that might tell us what is going on. So right now I'm calling it prim2. We don't have anything that's setting that equal to anything. So it might be part of the initializer. We may have to get into the game and see. But one thing we do know, and we could do this since we know it, is that this offset C here is going to be an unsigned 8, and we'll just call it unknown C. Not original, but it's something. So 7C plus C is 88. Oh, and I have prim 4 in that place, which is wrong. Let's see if we have anything. Nothing's using that, so that's okay. And so I know that there's going to be E here as well, so I'm going to do a couple... it'll be A. So we have 88. The U8 unknown 88. Do 80. We don't know of anything at 89 yet. And I don't know of anything at B yet. So we know we have 88 and 8A. Let's fix those. So we're going to change it to all rocks. No, 88. And the E we could change to 88. And it looks like I'm going to go one step further and treat those as Booleans. I like I was going to change this to true and false, but it looks like this is a plus plus. So much for that. 394. Let's just double check the type is right here. Store byte, yeah. That seems fine. And let's look at the 88 and see if that's always a Boolean. Looks like it. It's not the first time somebody's called me a Boolean. All right, will be the last. Yeah, Eldritch, good to have you back. Little known feature of Mac OS. See if your operating system does this. You can highlight text and then drag that text wherever you want and it'll move it. I'm going to try to get this case to be included. Same with this one. What I was trying to do earlier was see if I could ignore as much as possible the prim stuff that I know is wrong now. But we could get these other cases in place. So really, which that is probably fine. See about that. And now let's fix the mess that I've made. And this is why I didn't do it earlier. We do have offset 84. I wonder why this one didn't get replaced. This is bizarre. Oh, this looks like it's just M2C being silly. So actually this doesn't seem that bad necessarily. Can do this a little bit. Get things back to compiling. Should probably get things compiling before I continue on, since I have broken things so badly. 9:15 is our next error. Bunch of noise. So for functions like this, basically the non-optimized Metro works. So Code Warrior basically just starts flailing with registers and spilling things all over the place, and it's a mess. And nothing good happens, only bad. Then M2C comes in, and M2C can't make heads or tails of it. And so it starts flailing. This is the same as above as well. Very similar structure to a lot of these switches. That's what you'd kind of expect if you think one person is writing this. I think I'm gonna comment this part out because this has those structs again that I don't know what they are, and I'd rather ignore them. And there we go. We're back. So I have some loops here. I think what I found along the way here is we have more of these that are X. So again, this is M2C failing at doing pointer arithmetic. This is the same as 7 entities later. And so we'll fix all those. If we knew what this was, we could make a macro for it, which isn't the worst idea. And so as we know more about OROCs, it probably wouldn't be the worst idea to come back and add a macro. And I should probably look for any like self plus X. That is, those can be replaced pretty easily. 78 is going to be 2. Can't even do that one in my head. Okay, we got all those. Don't have to worry about that. So another thing that I'm seeing quite a bit is calls to this 070 function. It looks like they're always supposed to have one argument, but sometimes they don't. So I'm going to look for cases where there's a comma. And those should be fixed. And so those are times when basically there's something in the argument registers, and M2C can't figure out that those shouldn't be in the argument registers. But we know better. Oh, 1E? I could do this replacement with regular expression as well, but I'm not gonna. I didn't think there would be this many of them. So we're back at the top. We got them all. Okay, so I think the next thing, unfortunately, is trying to figure out what that strange type is. And I think there's nothing to it but to do it. Delay for a second though. Oh, here's our offset Y probably. And I'm surprised that that's not offset X, but is there anything wrong with getting rid of just all the casts blanketly? I don't think so. Let's do that. I want to do them one at a time. No, this is weird. 238. Here we're treating it as a sine 16, possibly. That's extra wrong. Maybe it's a bug. Who knows? Okay, so we have a couple things to deal with. We have to figure out what this mystery type is. Hey Modzilla, good to have you back. Let's see. I haven't looked. Things have been going a little slower lately. Last I checked, we were just over 50% of the way done. And yeah, I think most of the first castle is done. I know Xanimo is working on getting a little cleaner progress monitoring. We're tracking data. I don't know if it's accurate, but we don't have that out. To look at, but yeah, it does look like the entire first castle done. There's one function in main. DRA still? Or is it ST0? I need to look at that. There was one function that was like so close to being done. It had been sticking around just about forever. And yeah, it looks like maybe 2/3 of the Inverse Castle. Inverse Castle should go a little quicker. And then most of the bosses. BO6 is actually done for the most part. I just need to... it's duplicate code from BO4. Yeah, that's what I'm working on, trying to get there. There's not a ton of outside of this monster function for Olrox. The other code really is a lot of like just the other enemies that he spawns, and that's all duplicate. And most of that I've been able to dedupe. So there are going to be some doozies, I'm sure, but yeah, we'll see what they are. Let's look at some of these other, before I get into that mystery field, let's look at some of these other fields. Like I said, I want to delay as long as possible. This looks like it, oh, it's not a Boolean, it's, but it is some additional state. Yeah, I just picked it up last week, so pretty new. So let's look at that. We're at offset 1F, which is 9B. Right now that's not being used for anything, so we're going to make a bunch of unsigned 8s here. Yeah, I should have more rocks up there. That'll be on my to-do list. Our branch is backwards. Which is interesting. That's the right thing? No. Oh, that's strange. I'm not going to worry too much about that yet. All right, what are we going to worry about next? Let's look for the other illegals and see how many of those we can figure out. We may have to. 1C looks like it may be a Boolean. We have D as well. 1C, 1E, and D. 14, no idea what that's going to be. Looks like D should be straightforward. So C plus D is 8, 9. 2E, 2D, 2C. These are all being accessed as unsigned 8s as well. Oh, 30. There's a lot of data here. I guess let's do 1D next. So let's see. This 1D is 99. We have room for that already. Oh, I need to do the math. Looks like I screwed something up. Oh, drat. Oh, drat. And that's not moving the match any further. We're just switching from array access to field access, which doesn't change much. It's 90. So we have another, it looks like, collection of unsigned 8s. And I like keeping these anonymous until I know that I need them. For better or worse. Odd that this is being passed by reference. Not sure if that's correct. Actually, let's undo that and look at the other references to 14, and if we can see what that is. So it's always by reference. I don't know if I'm comfortable treating that as a unsigned value then, or as an unsigned 8. I guess we can look to see up here, are we loading? We won't know because it's by reference. So we're loading the address, and so I'm not sure why M2C thought that this was a unsigned 8. Unless there's something else related to this function. But that's always taking a pointer. So I'm gonna undo that. I don't think that that's necessarily correct. I don't think we can say anything about that quite yet. Okay. Other illegals. One C. Maybe this is why, because 1C has to be a Oh no, this is not in the same place. This is Unknown 98. Yeah, unfortunately, the bosses are also the hardest, I found, and that could just be me not being very good at what I do. In general, I think the logic there is just trickier than the simpler enemies. Okay, so we have a 1E2, which I think we should, in these 2D, 2E, and 2C. 1E should be straightforward. 1E is 9A, which I think is already there. And I guess the next ones are, so like I said, I don't agree with that one. I think it's just these later ones. Means we're gonna have to add a bunch of padding. Ooh, more later. And then offset 14, which we can't tell what that is. We can go back and look at the PlayStation version and see if that helps us out at all. So let's do the twos, so 2E, D, and C. That's at offset A8. We're actually pretty close already. So here we would be at A0, A4, and that gets us to A8, which is unknown 2C, and we know there's going to be unknown 2C, D, E, and then one more anonymous one. But I'm going to call them 2C, well, A8, A9, and AA. Go all those up. Oh, I did 2D, I meant to do 2C. And I think eventually we'll probably play through and see what that is. It would be nice to generate like VRAM addresses as comments next to the code. It seems like something a debugger might do. Probably a year and a half now, I tried to get a debugger going that would link back to the code. So you should be able to connect GCC to DuckStation. Sorry, GDB. It just never worked well for me. happened to... Oh... Yeah, it's going well. Glad to be in your feed. Thanks for having me. These as well. Appreciate everybody, as always, who comes by. I'm actually gonna have to... What happened to my timer? I thought I had a timer going. Guess not. I'm gonna have to sign off pretty soon. Run some errands. I think and I hope that oh, we have all the 30s too. Okay, one more set of these, and then the only one we'll have left is the offset 14, where I don't know what that is yet. So let's go 7C plus, I think it's 30, 31, and 32? 30 and 31 at least. So let's get those two. That's at AC. Oh, that's closer than I expected. And do we have a 32 somewhere? We don't. All right, so that leaves us just with the 14s now. 14, 14, 14. Offset 10 as well, so that's 8C. Do I have anything at 8C yet? I do, but I don't think it's right. And offset A. Oh, there's more than I thought. Offset A is going to be what? 8.6. Ooh, that cuts right in the middle of Prim 3. Oh, but it's unsigned 16. Never mind. Yeah, this is that same. I'll buy that it's unsigned. So that's not right, though. Yeah, definitely. I've come to hate Rust a lot less than I used to. I don't know if that's a glowing recommendation, but oh, I need to fix my declarations. The colon means it's a bit field, so you can't put the identifier name in bit field. Okay, so work is not quite done yet. 1E, I thought 1E was done, but my search didn't catch it. So I'm going back through one more time just to see which fields do we still not have. 14 bytes in, 20 bytes in, and that looks like it. And the 14 byte in one, I'm not convinced that's actually what it is. So let's go to the first instance of that. Which is case 3 of case 18, as far as I can tell. And let's see what interesting. How could that be? So M2C thinks the same thing on the PlayStation. And that's a little surprising to me. One thing I also want to do, make sure I have the right primitive here. And yeah, I do. And copy my Olrox struct over. This is probably going to break the PlayStation version, but that's okay. I never even got the PlayStation 1 compiling at all. That's sad. Now that was at 50%. That's better, considering I don't have a lot of the code even uncommented. So that's not the worst. I don't necessarily like that it's not the US version, but that's okay. All right, I'm gonna have to call it a day. That's my timer. If you want to know more about the Symphony of the Night decompilation project, go to soten.z.dev to learn more, and I'll see you later.